Hey everyone, good to see you all today. Good afternoon, good morning, maybe good evening, depending on where you are. My name is Chris Munns. I lead developer advocacy for serverless at AWS, and I'm joined here by James. I didn't hear James. I don't know if that's me or not.
Okay, I think I'm live now.
There you go. Cool.
Great.
Say hi, James.
I am James Bezic. I'm a developer advocate here in the AWS serverless team. But today we're going to be talking about getting started with S3 and Lambda. Just very quickly, here are my details. The most important thing on this slide is my email address and my Twitter handle. So if you have any questions at all about serverless, you can reach out to Chris, myself, or any of the DA team, and we'll be happy to help you the best we can. But today we've just got 3 things we want to cover in 25 minutes. So we're going to really.
Sorry, real quick. I thought that hat was the most important thing on that slide.
I get that a lot, funnily enough. But you'll be seeing good pictures of me in this demo coming up. So we've got more to come. But yeah, there's 3 things we want to cover in 25 minutes. I'm going to be packing quite a lot into this. We want to talk a little bit about how S3 and Lambda came together and why they're useful together. And then you may have heard about this image processing example. It's kind of the canonical example that's given for putting the 2 services together. We're going to delve into that a little bit and talk about how that works. And then most of this period of time we have, I'm going to be showing you some code and doing some live demos. So Chris, tell us a little bit about how it was that S3 and Lambda end up being services that work together.
Yeah. Robert kind of dropped maybe some hints at it about, services made to fit together. The history behind Lambda is that it originally actually started as a compute service component to S3. So it's kind of almost like in the last 6 years with the announcement that we just had, we've come back to that original premise again, but it made even easier. But you did have, back in 2013 or so, I guess, this thought that we needed some way to make it easier to process data in S3. And so Lambda was originally formed inside of the S3 product team, eventually spun out and grew into the thing that we know as serverless today. And so again, with the announcement that you just saw, it's going to even simplify what we had, which was this original promise of I'm going to put data into an S3 bucket and I want to almost immediately process it in some form or fashion. So it's pretty exciting to see that, pretty exciting to see what customers are going to do with it. And I'm looking forward to get hands-on with it. I know that we heard about it and we talked to some of the S3 product team about it. I have yet to be hands-on with it myself. And so I'm looking forward to getting a chance to do that later today.
Yeah, it's very exciting. And so when you look at how S3 and Lambda work up to today, essentially S3 can invoke Lambda when objects arrive in an S3 bucket or when they're deleted or when they're copied. And a whole host of other events can also invoke a Lambda function. And so there's some really interesting things you can do with this. So I thought I'd just mention some of the characteristics of both services because it's interesting how you can draw on the benefits of each service when you combine them for your applications. So, S3, as you know, is object-based. It provides 11 nines of durability, and it has virtually limitless storage for your workload. And it also provides lifecycle management, so you can expire objects or move storage tiers based upon various rules. And it supports encryption and provides a fine-grained permission model. Lambda, on the other hand, is our functions as a service offering that's at the heart of the AWS serverless portfolio, and it provides you with 1 millisecond billing, so you're charged for the length of time that you use the service. And you can configure memory, which also controls the amount of virtual CPU available to your code. It supports a number of runtimes, including Node, Python, .NET, Go, and Java, and you can also bring your own runtime too. So we have customers running PHP, Erlang, COBOL, really pretty much anything you can imagine. And it's also stateless, it scales automatically, and it's event-driven. And the reason for highlighting all of these services capabilities is really when you're building these workloads, you can draw a lot of the benefits of these without having to write custom code.
Yeah, we got a couple of questions here in the chat about like what is Lambda, what does it mean? And we've been using the term and talking about it here for a little while. Going back to what James just said again, Lambda is a compute service now at AWS, and it kind of changes the model that you think about how you build an application, how you operate an application, with one of the key goals being to remove almost all of the typical administrator burden. So, with a Lambda function, you're not dealing with the operating system, the underlying, say, compute instance or compute infrastructure. You're not thinking about today ports or sockets or anything like that. You're able to just write your application code, and your code will be run in response to another event happening, potentially with another AWS service or via an API call that then causes that code to be executed. And so, again, it's a slightly different model, but one that we see growing very rapidly in usage with customers here at AWS. Back at reInvent 2020, just a couple of months ago here, there was an awesome stat by Andy Jassy, who is AWS's CEO, currently AWS's CEO, soon to be Amazon.com CEO, about how internally at Amazon, it was used in just about half of the new applications that were built in 2020. So serverless is Lambda is pretty cool stuff. It falls into this umbrella of serverless, which means, a bigger, wider thing. Important not to get the two terms too mixed up, I'd say.
Yeah. And if you've worked with Lambda in any way, you might have come across this example. This is really the canonical example of how S3 and Lambda work together. It's to do with image resizing. And we have lots of customers using this in media companies and gaming companies. And the very simple way this works is that you have an S3 bucket that exists that contains all of these images. And this could be hundreds of millions of different objects. And every time that a new image is put into that bucket, that invokes a Lambda function. The Lambda function then has some code that uses a library such as ImageMagick, for example, to then optimize or resize the image. And the output image is then stored in an S3 bucket, the second S3 bucket. And so there's many implementations of this online with lots of different runtimes and different graphics libraries available. And we'll be looking at some of this in the code examples.
Yeah, and that image there is really like the initial spark or gene of what drove Amazon. This idea that that drove Lambda. Since S3 first launched, many moons ago, here we are celebrating its birthday. There was that issue of, how do I know that data has been put into a bucket? How do I then take that data and perform some sort of compute action on top of that? And so, again, initially the goal here was put data in S3, run this code in response to that. And so this image that James has up is that like de facto initial spark of thought that led to Lambda.
Yeah. And so what's really interesting to me, when I first came across serverless and Lambda, I saw this example, but what's not always obvious when you look at it is the scaling aspect of this. So it's fine when you look at one image at a time, but in production workloads where you have tens of thousands of images, especially when you have mobile apps and web apps, and they have spiky patterns in terms of uploads, you can get tens of thousands of these uploaded all at once. Now, in this example, what happens is the Lambda function then gets scaled up by the Lambda service. And I'll show this in the demo in a few minutes. But the speed at which it happens is truly remarkable. And then when the traffic goes away and everything scales down, you're no longer paying for your Lambda function. So I want to show you a quick example before we go into the code. We have a workshop called Innovator Island, which you can visit at the URL on the screen, s12d.com/Innovator Island. And this takes the image processing example just a little bit further, where we do some compositing. So compositing is a technique often used in TV and movies where you have green screen images, which are then, you remove the green screen and replace it with some other background. And so in this example, in the workshop, visitors take a picture of themselves against a green screen, and then that gets dropped into a first S3 bucket. When the object is durably written to the bucket, that invokes a chroma key Lambda function. Now, this Lambda function uses a library called OpenCV, which you can use for processing images. And it uses that to strip out the green background. Once that image processing is complete, that's written to a second S3 bucket. Writing to the second bucket triggers the next Lambda function, which is a compositing function. And that takes other graphics assets to stack those together and create the final image, which the workshop attendees would then see on their phone. So we're going to step through this and see exactly how this works. Let's take a look at the code. So all of the code I'm going to show you today comes from this GitHub repo, and you can get to it using an URL I'll share at the end, so you don't need to worry about copying it down right now. I've gone into Cloud9, which is a cloud-based IDE that you can find in the AWS console, and I've already git cloned all of the code on the left. So first, I want to show you that resizing example where we take an image and we resize it. So what I'm going to do here, I'm using an infrastructure as code framework called SAM, the Serverless Application Model. And this provides an easier way for us to build resources in the AWS cloud. And since all of our examples use S3 buckets and Lambda functions, it provides an easy way for us to control and deploy both in our application. So in this SAM template, you'll see that we've defined two buckets here. One is a source bucket and one is a destination bucket. A little bit further down, there is a Lambda function. Now in the YAML, I state where the code can be found, which is in this code subfolder just here. I state that the runtime is Node.js 12, and it has 2 megabytes of RAM. With Lambda, you can specify anything from 128 megabytes up to 10 gigabytes. Now we're going to use this graphics magic library, and I'm importing that as a Lambda layer. And then the rest of this provides IAM access to those buckets. And then most critically is the event that triggers the Lambda function. Remember, Lambda functions don't do anything unless something invokes them. So in this case, when the source bucket receives a new object with a suffix of JPEG, an image, that will invoke this Lambda function. So if I go to S3, I've deployed all of these different applications. We've got the source and the destination bucket in my list here. I have that photo that we saw in the original deck. That's me against the green screen. So I'm going to copy that photo into that bucket. Oops. Let's put S3 in there. Oh, I'm not in the directory. Let's try that again.
Live demos here, folks. You gotta know that sometimes things are going to go astray.
So what you'll see there is I've copied this image up into that bucket. And if I go into the destination bucket, I'll just open that up here. What we'll see is there's now an image that's appeared in this bucket. What I'll do, I'll go back to my console because it's easier to manipulate this. I'm going to download this image from that destination bucket. I'm going to copy that locally. Right, JPEG. That downloads this image file. Actually, was it called that? I didn't remember the name of my own file. Let's try that again.
Someone was asking how you got the object into the bucket, and that because you're zooming through your command line commands here, but that was a command line copy that led to that. To be clear, yeah,
it was. What I'll do is I'll just download it here. I'll do it from the console.
Yeah, I
just wait for that to download.
I could log in and push it from my side too, I think, if you need me to.
Okay. Okay, so that essentially has removed the background off of that image. So that has actually resized that image to be smaller. So the image is now downloaded here, and that's actually smaller than the original one that we uploaded. So that's interesting by itself, but it's just one image. And really you want to see what happens when this operation happens at scale. So what I did is I went into my photo album and I downloaded hundreds of images here. So quite a few here. These are all off of my phone. I think there's 158 images there, and it's pretty large. Yeah, 591 megabytes of images. So what I want to do is I'm going to upload all of these, my source directory, sorry, for my photos directory to the source bucket. Using the recursive flag. Those will just copy absolutely everything. Now this is, because this is Cloud9, this will be fairly fast because it's on the Amazon network. It's not doing it from home. And so all of those images have now been uploaded. And if I go to that destination bucket, just wait for these to load, you'll see now that there are hundreds of these images that have now already been resized. So we've got 159 there. Now what's interesting is when you go to the Lambda console, and I look at how that function performed, what happens here, I'll just go to this second one. What happens is that Lambda scales up to process all of those objects that arrived in the bucket. So you'll see in my metrics here, I've got 158 different invocations, and that occurred across 76 concurrent different functions. So Lambda, when it saw all this traffic arriving, simply scaled up the number of execution environments and kept up with the traffic. And now that I haven't got any new files being copied up to the S3 bucket, everything is stopped and I'm no longer paying for my Lambda functions. So that's a good example of how Lambda really can scale up very aggressively when you have a workload that receives suddenly a lot of traffic.
Yeah, and let's be clear again, right? We aren't configuring auto scaling. We're not configuring any instances ourselves. You didn't have to go and as part of this, configure any operating systems or daemons or anything like that. Really, you in this case use SAM, which we're going to talk about a little bit later here, which is a serverless application model and its CLI tool to help deploy code. You deployed your app, which I think if you pull open the app code for this, it's like 90-ish lines of code, I think, if I recall, for the first one here.
Yeah,
this one's not even that. Yeah, 50. Yeah. So it's just that code. And then you threw a whole lot of data at it, and boom, it all got processed pretty quickly. So that's pretty awesome.
And so since this is a very short session, I'm going to show you the next example. And all of this code you can access on GitHub at the link I'll give you in just a moment. But I just want to show you this second example we talked about, where we use chroma key and we use compositing with that as well, with 2 different buckets. And so I'll just switch to the green screen example. Now, this is the SAM template. This looks very similar to the last one, but there's a little bit more complexity. We've got 3 buckets instead of 2. So we've got an upload bucket, a processing bucket for receiving the chroma keyed image, and then the final bucket, which receives the composited image. And a little bit further down, there's 2 Lambda functions. This is the chroma key Lambda function, and that's the OpenCV library. It's a Python library for processing images. It has some environment variables and policies there. This is the event that triggers this. Again, this is when an object arrives in the bucket of type with a suffix of JPEG. And then, unlike the last example, we have a second Lambda function that does the compositing. And the interesting thing here is that this is a Node.js function, whereas the previous one is a Lambda function. So you can quite easily combine runtimes for different parts of your workload and choose the best runtime for the job. This second Lambda function responds to the second bucket receiving PNG files. In this case, we're going to take the same image that I've been using. This is a green screen image. And I'll just look up the bucket name so we can copy that across. I'll just find my...
And I just pasted into the chat for folks who are here the GitHub repo where you can find this code. So the code that James is running and showing right now is all available there. And so you can follow along, read along, and do this at whenever you get an opportunity.
Yep. I'm going to upload that image to that very first bucket. That's now uploaded. And if we then go to the processing bucket, you'll see that has a PNG file that has now appeared. That's the one without the background. If I open this, we'll just download that. And that's just opening on my machine. So this is the image result from there, where it's the picture of me without the green screen. But now if we go to the final bucket, what you'll see here is a final JPG file. And this is the final composited image. And so what you can do by chaining Lambda functions like this is you can have a bucket call a Lambda function that puts something in a second bucket that calls another Lambda function. And again, this is another function that really consists of about 100 lines of code and is doing nothing more than the compositing. It doesn't do anything special to manage any of the scaling. So all of these examples I've shown you and a lot more are available at this resource link we've put together, s12d.com/S3 Lambda. Everything is there, including a video series that I did fairly recently that talks through some more of these examples. So just to give you a quick wrap up of what you can do with this. This is a very, very scalable solution for dealing with data like video files or image files. So the service will scale up automatically as lots of objects get received into the bucket. It's event driven, so Lambda only comes to life when an event happens that causes it to run, in this case, an S3 event. But that means that also you only pay for value, that you're paying each time the Lambda function is invoked, and you're paying for storage in S3, but you're not paying for fleets of servers sitting around waiting for traffic. And this also makes it very attributable. If you're building customer projects for clients, it's easy to work out which clients are costing money because you can attribute the cost. In terms of security, security is job number one here at AWS, but we all have a really important role to play in security as well. If you use your access control list and your bucket policies and your IAM policies using the principles of least privilege, you can actually build very secure applications that need minimal maintenance. And finally, serverless. So that's great. That means no instances to patch, no infrastructure to worry about. It simply sits there and waits for events to run and lets you focus on the code that you want to write. So this is a good time to mention Serverless Land for a lot more serverless learning resources. This is run by the DA team, and this is a collection of blogs, videos, learning paths, and other resources that can help you learn how to build serverless workloads. And we update this fairly frequently. So that concludes this first presentation. So my name is James Bezic, and Chris Munz is here as well. I've put my details here so you can contact us with any questions you have.